Okay, so let's get into this. Imagine you're setting up a new workstation, you need a DisplayPort cable, you go online and expect to pay, I don't know, 20 bucks.
Yeah, maybe 30 on the high end.
And then you see this one, the Kramer CLS-AOCDP UF-33. It's 10 meters, so about 33 feet, and the list price is $400.
That's definitely a moment of real sticker shock.
Right. Even on sale, it's like $320.
Yeah.
So I think our mission here is pretty clear.
Yeah.
We have to justify that price. What in the world is happening inside this black cord to make it cost as much as a new monitor?
Well, the first thing is you have to sort of stop thinking of it as just a cable.
Okay.
This is really an active piece of electronics that's just, shaped like a cord. It's built to solve a very specific physics problem.
And we're talking about the problem of moving 8K resolution
Right.
over a long distance.
We are. 8K at 60 hertz, which is a resolution of 7680 by 4320. To push that many pixels, you need a massive data rate. We're talking 32.4 gigabits per second.
That's the HBR3 standard.
High bitrate 3, exactly.
Yeah. And this is where a normal copper cable just runs into a wall. If you try to send that signal through 33 feet of regular copper, you're going to get, what, flickering, digital snow?
Or just nothing, a black screen. The signal just degrades completely. The resistance is too high over that distance. So Kramer's solution was to basically ditch copper for the main signal.
So what are they using?
This is an AOC, Active Optical Cable. Inside that jacket, there are actually 4 tiny strands of multi-mode fiber optic glass.
So it's converting the electrical signal from the graphics card into light.
Precisely, into pulses of light. Light doesn't care about electrical resistance, so it can carry that huge 32.4 gigabit stream, the full 10 meters,
Right.
with, basically zero degradation.
Okay, but hang on. This is the part that I think is the real engineering flex. Fiber is great for data, but glass can't carry electricity, can it?
It cannot.
And a DisplayPort connection needs power. It needs to do that handshake between the monitor and the PC.
And that's where the hybrid part of the design comes in.
Mm.
If you were to strip this cable open, and please don't, you wouldn't just find the glass.
Oh, okay.
You'd also find 8 copper wires running right alongside the fiber.
So it's a hybrid architecture.
It has to be. The copper handles all the low bandwidth stuff. The handshake, the monitor detection, and crucially, the power.
Which solves the brick problem. Usually with active cables, you need an external power supply, a little USB plug or a big wall wart.
Right.
But the spec sheet here says this thing pulls less than half a watt.
And it siphons that tiny amount of power directly from the DisplayPort connector itself using those copper wires.
Okay.
So you get the speed of fiber, but the plug-and-play simplicity of a normal cable.
That is very, very sleek. And it's not just video, is it? It's doing audio, too.
Oh, yeah, up to 8 channels of 24-bit uncompressed audio. It's a full pipeline.
But there's another spec here that tells me this isn't for my gaming setup at home. It's the jacket rating. LSHF.
Low smoke, halogen-free.
And why is that a big deal?
That is everything for professional installers. If you're running a cable through a plenum space, like a ceiling, or inside a wall in a school or an office, the fire code is incredibly strict.
Because normal PVC cables release toxic gas if they burn.
Exactly. Nasty halogen gas.
Yeah.
This material doesn't. It's designed to be installed as permanent building infrastructure and just be safe.
The word permanent makes me a little nervous when we're talking about glass, though. I mean, isn't fiber famously fragile? What happens when a contractor yanks this thing through a conduit?
That's sort of an old fear. Modern fiber is surprisingly tough. The spec on this lists a compression resistance of 300 newtons. It's durable.
What about the bend radius?
48 millimeters, so you can loop it pretty tightly without breaking the glass or losing the signal. It's built to be installed and forgotten.
So if we wrap this all up, you're not paying for a cable. You're paying for a self-powered 33-foot data pipeline that sends zero latency light and won't poison you in a fire.
You're paying to effectively delete the distance between your source and your screen.
It really changes how you look at a blank wall, doesn't it? You start to realize that to keep up with the screens we watch every day, with 8K and beyond, we're slowly replacing the copper age with the photon age. Right inside the wall.